viewers. I'm Kawing.
I'm Janji.
I'm Shazwan.
I'm Shazu.
And I'm Shani, and we are from Group M11.
Today's video is about the demonstration of our EMC311 project, which is a mini conveyor system powered by a PLC and controlled using a Raspberry Pi operating system. This video will show us about the system component, schematic and circuit, coding, actual process, limitation of the system, and problem faced during the execution of this project. So now, let's get started.
In this project, we are tasked to design a simple conveyor belt system to move a carrier box to specific locations where the distribution of ping pong balls will be performed. In this project, we have two distribution pipes filled with ping pong balls and are open or closed using solenoid controls pneumatic pistons. When the carrier box moves to a correct position, detected by the two proximity sensors, the box will stop and the distribution of ping pong balls will be performed. In this project, our 8 ping pong balls will be distributed in a 2 balls per distribution order, which means that at the first distribution pipe, 2 balls will be dropped into our carrier box and moved to the next distribution pipe, where another 2 balls will be dropped and the box will come back. This process will be repeated until all 8 ping pong balls are successfully distributed.
Our system is a simple conveyor system using pneumatic pistons. The pneumatic pistons used are 3 double-acting pistons with 5 valves and 1 single-acting piston with 3 valves. They extend and retract using pneumatic pressure, which is controlled by solenoids. And next, we have relays, 2 relays. The first relay, or relay A, is used to control the motion, while relay B is used to control the direction of the conveyor. And next, we have PLC, or Programmable Logic Controller. PLC in this experiment is used as power supply only for our conveyor. In addition, we have 2 proximity sensors. These sensors are used to detect the presence of the box when the box is at the right position, and it will tell the system to temporarily stop for the distribution of the ping pong balls. And next, we have our conveyor belt. This conveyor belt is powered by direct current. When the belt is turned on, it will simply move until the right commands are given.
Now we will move to the connections. Here we can see we have an interface circuit board, a breadboard, and our Raspberry Pi. The interface circuit board is used to connect all of the components, while our breadboard is used to connect all the sensor system. And finally, our Raspberry Pi is used to control the system using a specifically written code which is run by Python. The connections are made as in the following of the schematic diagram.
Now I will explain the schematic of our project. Firstly, the whole system is powered by the PLC, which is shown here. All components' live wires are connected to the positive terminal of the PLC. For the 2 relays and the 4 solenoid cylinders, the other ends are connected to the interface circuit board. For the 2 switches, the other ends are connected to the Raspberry Pi directly. From the interface circuit board, all connections are made to the Pi directly. From the interface circuit board, there is another ground which will also connect to the negative terminal of the PLC, which acts as a ground. For the 2 proximity sensors, the live wires, which is brown in color, will connect to the positive terminal of the PLC. The blue wire, which acts as a ground, will connect to the negative terminal of the PLC, and the black wire will connect to the interface circuit board. For the DHT22 humidity sensor, the red wire will connect to a 3.3 volt power supply, which is a GPIO pin. For the black wire is connected to a ground GPIO pin, and the last wire is connected to another GPIO pin. The Raspberry Pi are then connected to an external power supply and the control interface.
Next, I will explain about the coding for our project. Firstly, the components are assigned to the respective GPIO pin. Variable n is the number of times the box has moved. Variable x is the number of balls that are in the box. Next, the GPIO pin is set up as output or input, and the initial conditions are defined. So when the black switch is pressed, the conveyor belt starts moving. Note that the relay A controls the movement of the conveyor belt and relay B controls the direction. When the proximity sensor A is pressed, the conveyor belt stops moving and 2 balls are collected, and the conveyor belt starts move again. The same goes to the proximity sensor B, but this time after they collect the ping pong balls, the conveyor belt moves to the opposite direction. This process are repeated until all 8 balls are collected. Also note that if red switch is pressed or the humidity is over 75, the process is terminated. If the black switch is not pressed, the system will display to tell us to press the black switch. When the code is run, the system will request to press the black switch, and when the black switch is pressed, the conveyor belt will start moving. When the proximity sensor detects the box, the conveyor belt will stop moving and 2 balls will be collected. The same goes to another proximity sensor, and the process is repeated until all 8 balls are collected. The values on the screens are the humidity readings from the DHT22 humidity sensor. Once all 8 balls are collected, the box will move back to the starting position and the system will show that the process is complete. This section shows how the system responds when the red switch is pressed. And this section shows how the system responds when the humidity is over 75.
Now I will explain the actual process. When the back button is pressed, the box will start to move to the right. When the box reaches the first proximity sensor, relay air is off and 2 ping pong balls are deposited into the box. Then relay air is on and the box starts to move to the right. When the box reaches the second proximity sensor, relay air is off and 2 more ping pong balls are deposited. Here, relay A and B are on to switch the conveyor directions to the left. When the box reaches the first proximity sensor again, both relay are off, the box stops and 2 more ping pong balls are deposited. Relay A is again on and the box moves to the right. When the box reaches the second proximity sensor for the last time, the last 2 ping pong balls will be deposited into the box. Both relays are again on and the box returns to its initial position and the process is completed.
During the entire course of the project, we have faced a few difficulties. Firstly, the lack of further knowledge in electric and electronic technologies causes more time in studying and understanding the connection facts given. Time constraint is also another big problem. As we face the difficulties in connecting the components, we also have a limited time in doing our project because our lab session is limited. Also, we have difficulties in doing the project because we also need to do assignments on Raspberry Pi with group assignments. Next, we also face difficulties in the components used in this project. The lab assistants give us the components which are faulty and we need to check whether the component can be used or not.
As a conclusion, our system, which integrates relays, sensors, and other electronic components into a mechanical conveyor belt system, is a success, as all 8 ping pong balls are successfully deposited into a carrier box using programming, and a Raspberry Pi microcontroller.